Hello everyone. In this video I am going to demonstrate modified current transformer using 1:1 CT, Arduino Uno, LM324 as amplifier and an envelope detector. As you can remember, the same thing I have made before. I was using current transformer, I was using this amplifier and I was feeding the output to Arduino Uno. But my output was not very stable. What I have seen in the previous video, as you remember, if you have seen the previous video, you can remember I was able to measure only 4.79 volts DC. After that I was not able to measure any voltage and the milliamps I was measuring was only 400 milliamps. And the difference between the milliamps with Arduino was only 50 milliamps, but up to 400 milliamps I was able to measure. I was using a circuit where I was using this filter capacitor with a resistance in series. So in this circuit what was happening, when the capacitor was charging it was following this profile, and when it was charging, after charging it cannot work anything, it cannot do anything. This was like a DC charging. However, in this video I have modified this circuit and I am using the concept of an envelope detector. As you can see here, this is the modified circuit. In this circuit I have used a 1 microfarad 50 volt capacitor and a 100k resistance in parallel. So this is an envelope detector circuit. How does an envelope detector circuit works? If you can see the waveform, suppose this is the desired wave, and due to this AC output the real wave is like this. So if you increase the R and C value much greater than the sin theta of the wave, then in that case it will follow this curve. So here the C and R multiplier is 1 microfarad and 100k. So I have used this circuit and I can see the response is pretty good. You can see this is the response table. I can go up to 700 milliamps at 5 volts. However, in the previous circuit with capacitor as a filter, I was going only up to 400 milliamps with this capacitor as a filter. This is the conventional mode. But with envelope detector mode, I can reach up to 700 milliamps. I can reach up to 800 milliamps also, but the voltage was getting high, so I need to rescale it. I didn't rescale, I just reached up to 700 milliamps. And what I have noticed that on each scale there was a difference of 50 milliamps. Somewhere near 50 milliamps there was a difference on each scale almost. So that 50 milliamps difference can be, that is like a backlash. So that can be rectified easily with software compensation. That is not the issue here. The issue is, the previous video I was using only this filter. So it was following the capacitor charging curve. But now it is following the envelope detection curve. So this curve I am making an envelope and I am able to measure the voltage properly. So I will demonstrate you how the circuit is behaving. As you can see, this is the same current transformer I used in the previous video. And this is the same amplifier. The same amplifier, only I have reduced the gain of the amplifier. Instead of 10k I am using 4.7k resistance. You can see here, instead of 10k in the previous circuit, here it was 10k. So I reduced it to 4.7k because the voltage was becoming very high. That's why in order to reduce the voltage I just reduced the gain. Here I just reduced the gain. Rather I would have used a potentiometer here, but I just reduced the gain here. Okay, so let us see the circuit. So here in the circuit it is the gain for it is, you can see here the 4.7k resistors, this one and this one. Okay, and the output there is a Schottky rectifier. This is the Schottky rectifier. You can see this one looks like a transistor. This is the filter capacitor and this is the 100k resistance. So this filter capacitor and this 100K resistance is forming the envelope detector. So now let us see the readings. So when I am passing a current of 500 milliamps, you can see 500 milliamps current is passing. This is the bulb glowing, and you can see here the voltage is 3.8 volts DC, and here you can see 584 milliamps. You can see there is some error. So there are some errors, 574 milliamps. We need some approximation here. So this is the LCD reading. So this is how the circuit is behaving. The circuit is now improvised. Only the software I need to work upon. So thanks a lot. Thanks for watching.